Siyanamukela ohlelweni lwe-Ithala Edu Platform enilethulelwa ngezilokotho ezinhle Ithala kanye ne-Go Digital SA Foundation. Thamelani izifundo ze-mathematics, i-accounting, isiZulu ulimi lwasekhaya, isiNgisi, i-FAL, i-physical science, i-geography, ezobuchwepheshe, i-computer applications technology kanye namaklasi e-learner wellness okungukuzilolonga ngokomqondo kanye nomzimba. Lezi zifundo zethulwa nsuku zonke kusukela ngoMsombuluko kuya ngoLwesihlanu kuqala ngehora lesi-4 kuya kwelesihlanu u-4 kuya ku-5 ntambama nangoMgqibelo kusukela ligamanxe ihora lesi-8 8:30 kuze kugamanxe ihora lokuqala emini 1:30. Zithameleni futhi lezi zifundo emsakazweni Ukhozi FM njalo ngoLwesine kusukela ngo-9 kuya ku-10 ebusuku. Ningangena ekhasini lethu lika-Facebook elithi Go Digital SA_movement noma kwi-YouTube uthi Go Digital SA Foundation. Siyethemba nizolijabulela lolu hlelo oluhlose ukunifundisa futhi lulekelele kulokho enikufunda ezikoleni zenu. Luthokozeleni-ke lolu hlelo nimeme nabo bonke abanye abafundi bebanga le-12 grade 12 ukuze nabo bazuze kulo futhi nonke nicijeleke ukuphumelela kwizivivinyo zenu zokuphela konyaka.
Sanibonani bafundi, sekuleso sikhathi manje se-physical sciences. We started with paper 1 last week, sasikhuluma nge-Doppler effect. Namhlanje sokhuluma nge-work energy and power. I-topic enkulu lena ku paper 1. Uzothola ku question 5. Question 5 idila nge-work energy and power. Njengoba igama lisho work energy and power, khona i-concept around i-work, khona i-concept around energy, kube ne-concept around i-power. Most of the time iphepha malisetwa kuhlezi kuna umbuzo hambisana ne-work, then kungenzeka kube i-energy. If it's not energy, then kungaba i-power. So lo mbuzo question 5 kanjalo. So on work energy and power, let's call energy ngoba it's a sort of revision. Energy nakwenza ka grade 10 and it's cutting khuluma nge-energy, khuluma ngama energy awu-2, potential energy or gravitational potential energy. Gravitational potential energy. This is the energy that an object has due to its position above a certain point or a reference point. The gravitational potential energy, lana ngizoyinema as EP. Kwezinye incwadi ungathola ukuthi EP kube ukuthi u-capital letter U just to express ukuthi i-symbol ye-potential energy. Now, when ngikhuluma nge-potential energy, I simply mean what? Gravitational potential energy. Maningi ama-potential energy, khona chemical potential energy, you have thermal potential energy. There are a lot of energies. Kodwa lana sikhuluma nge-gravitational potential energy. So mangithi potential energy, always know that it refers to low EP is equal to M times G times H. M is the mass of the object, G 9.8, the gravitational acceleration. The H is the height above the reference point. So uyakwazi ucalculate lokho as a mass, it has to be in kilograms. The G siyakwazi lokho is 9.8 and the unit is the meters per second squared. Then the H as the height, it is in meters. So that's how you calculate EP. Masikhuluma nge-reference point. Mhlambe sibe ne-example nalitafula then kube ne-object. Now the object is at the height mhlambe 1 meter. The object is just above the table at 1 meter. Then ube ne-height itafula libe nawo mhlambe 2 meter, just an example. Now masikhuluma nge-potential energy, it has to be relative to a point, like leli bhokisi leli li 1 meter above the table. So mawuthi so calculate potential energy relative to the top of the table, i-height esoyisebenzisa izoba 1 meter. Kodwa masebenzisa the ground where the table is, then so thatha le distance le plus le, so it could be what, 3 meters masikhuluma nge-height. So masebenzisa 1 meter, then we took the top of the table as our reference point. So the object will have a potential energy relative to the top of the table, but also singai calculator as relative to the ground. So sibuka leyo distance, leyo height from where the object is. That is the gravitational potential energy. Then the next type of energy is the kinetic energy. The kinetic energy, so inika a symbol as EK, but in other textbooks we're told to say capital letter K. That means what? Kinetic energy. So the kinetic energy is the energy an object has due to its motion. So only any object in motion in a kinetic energy. Makuno nje kunyakaza from one point to another point, then sikhuluma ngani nge-kinetic energy ngoba i-speed si involved. So i-kinetic energy yona si calculator as half mv squared. M is the mass again, so yamona ukuthi with potential energy i-mass bekhona, then with kinetic energy still we have also mass. Then the v is the speed of the object. The speed that has to be in meters per second. Don't forget about the square. The mass here is in kilograms. Ngoba sikhuluma ngama energy, siyazi ukuthi unit for energy is what? Ama joules. Joules. That is the unit for energy. Asibuke ukuthi an object, for example, sithathe example ukuthi there's an object that is thrown upward, mhlambe from a certain ground. Sine object mhlambe ino 2 kg, imass yale object mhlambe 2 kg, then siphose phezulu. By the time the object is still on the ground, siyabona ukuthi the height above the ground ubani u0. So ngaleso sikhathi sothini ukuthi i-potential energy yale object u0. When we throw the object upward, let's say mhlambe siphosa ngo 8 meters per second, until object velocity maximum at that point. So at that point siyakwazi ukuthola a kinetic energy ngoba sothi le object le, by the time we throw it upward, izoba ne kinetic energy ngoba isuka ngubani ngo 8 meters per second. So sothini, that will be half times the mass, that is 2, then we have what, 8 squared. So in that case is osinika abantu 64 joules. Kinetic energy of the object. Now let's observe one thing. Ngesikhathi le object isuka la iya phezulu, what is happening? What do we observe? Ngesikhathi move from the ground iya phezulu, the height from which the object is here increase. The height is increasing. Kanti siyazi ukuthi i-height ma increase, then i-potential energy is affecteka ngoba potential energy is mgh. So by the time si increase le height ngoba i-object is moving away from the ground, kusho ukuthi i-height here increase. This will lead to a point where potential energy nayo here increase. Right, so as the object move from this ground going upward, the potential energy yake increase ngoba the height above the ground here increase nayo. Then let's look at the kinetic energy. Kwenzekalani kwe kinetic energy? Siyazi ukuthi from vertical projectile motion, as the object goes up, it will free fall. As it goes up, the velocity yake here decrease. So as the velocity decreases, siyazi ukuthi kinetic energy is half mv squared. Njengoba velocity ya decrease akusho ukuthi ne kinetic energy decrease. So simona ukuthi khona into eziwu2 zenzeka la. For i-kinetic energy, as i-kinetic energy decrease, i-potential energy increase. Then the object izofika kwi-maximum height lapha phezulu, i-maximum height. Siyazi ukuthi at the maximum height i-velocity ye-object ubani u0. By the time it has u0, masi substitute u0 la kusho ukuthi ne-kinetic energy u0. So the time sisuka la from the ground with a velocity ga 8 meters per second. Then when the object is going up, a velocity decrease and the kinetic energy decrease until is a 0 meters per second. Right, when it's 0 meters per second, that is the maximum height. So siyakwazi futhi calculate the maximum height, and so thola ukuthi at that point i-potential energy nayo i-maximum ngoba sesisebenzisa leyo maximum height. So into singayibona ukuthi by the time a object ishona phezulu, the potential energy increases while kinetic energy decrease. So kungenzeka ngoba kunama energy awu2 singawahlanganisa lawo lama energy awu2, i-potential energy ne kinetic energy. So singathini during the motion singasebenzisa i-sum of the potential energy and the kinetic energy. Leyo sum leyo ibizwa ngani? Ibizwa mechanical energy. So the mechanical energy is just the sum of the gravitational potential energy and the kinetic energy. So sinani sine mechanical energy. Let's sotini o EM, the mechanical energy. So masiti sine kinetic mechanical energy A to EP plus EK singatini as from example yokuqala sibona ukuthi by the time kinetic energy decrease a potential energy increase. So kuyafana nokuthi when there is a decrease, when the object is falling down from the maximum height, into siyaziyo when the object is falling down, if velocity increase, and if the velocity increases kusho ukuthi ne kinetic energy increase. By the same time, when the object fall down, we find that the height above the ground is also decreasing, and if the height decreases, then the potential energy decrease. Masibuyela kule formula sibona ukuthi if the potential energy increases, then the kinetic energy is decreasing. But also, if we are in a situation where the potential energy is decreasing, the kinetic energy will be increasing. So lokhu kushelo ukuthi at the end, jalo noma kungashintsha potential energy kushintshe ne kinetic energy, low mechanical energy it doesn't change. It doesn't change. So singatheni makuthi for example calculate mechanical energy sithola ukuthi 100 joules, just an example. So ukuthi uhlanganise potential energy ne kinetic energy, they will always give you what? 100. They'll give you what? The 100 joules. So sisotini, if for example potential energy is 40 joules, kusho ukuthi ngaleso sikhathi kinetic energy is over 60 joules. Let's say we are increasing potential energy. By increasing the potential energy, magu increase the potential energy, let's say iso increase to 70 joules. Kusho ukuthi kinetic energy yona iso decrease, izoba 30 joules. So at the end, we find that every time mohlanganisa potential energy ne kinetic energy, uthola 100 joules. Nalana uthola 100 joules. Lokhu kuyasitshela ukuthi i-mechanical energy is conserved. Then singakhuluma conservation of mechanical energy. That is the principle of conservation of mechanical energy. Principle of conservation. Conservation of mechanical energy. So it's a mechanical energy, conservation of mechanical energy. Now, from what we've said, total mechanical energy I change, it's always conserved. But here, sinama conditions, finally see we isolated system. So, in terms of statement, in an isolated system, lana aike any external force. Isolated system the total angisivele besihlanganisa potential energy ne kinetic energy, so sokhuluma nge-total. The total mechanical energy is conserved. It is conserved or remains the same or does not change. So we have or is constant. Ungasebenzisa noma iliphi igama, it's fine. So it is constant, remains the same, or is conserved, like it's the same thing. So kusho ukuthi ngine object at a particular point A, mangihlanganisa potential energy plus kinetic energy yaleyo object, ngoba lokhu kunika bani mechanical energy, mhlambe at point A lokhu kuzolingana ne same potential energy ne kinetic energy at another point, mhlambe sothi at point B. So uzobona ukuthi masuka ku point A to point B, it's either you are increase potential energy, kodwa ngaleso sikhathi u increase potential energy, kinetic energy yona izo decrease. So at any given point, the sum of potential energy and kinetic energy won't change. So makushinja maku decrease ngo 20 ngale potential energy, kinetic energy izo increase ngani ngo 20. Remember also the law of conservation of energy. I think nakwenza grade 9. Energy cannot be destroyed or created. It can just be transformed from one form to another. So lana sotin potential energy ya transformega ibe kinetic energy. That's why makuthi ku decrease ngo 20 ku potential energy, kusho ukuthi kuya increase ngo 20 on the kinetic energy, and vice versa. Mak decrease potential energy by 10, kusho ukuthi potential energy is increase by 10. So you can now make use of the principle of conservation of mechanical energy, and then you do all the calculations. Senze isibalo esisodwa khona sobona ukuthi siyayizwa yini kahle lento engikhuluma ngayo. Right. Let's say sine bhokisi lalo 5 kg. A 5 kg block that is at rest. The object is at rest. Now it's lying on what? On a frictionless. Kusho ukuthi ayikho any external force. It is on a frictionless surface. Frictionless surface. Now this object, it's at a height of, let's say 4 meters. Just an example. At a height of 4 meters. Now into siqaphelela nokuthi the object is at rest. Masikhuluma at rest, it means the object is not moving and velocity yakhona u0. And siyazi ukuthi velocity, how is it related to kinetic energy? When the velocity is 0, then the kinetic energy is also 0 at that point. Right. Now, asibuke at this point, so the starting point, starting point A, lana at the ground, right? So the point B. Then umbuzo ungati, what is the velocity of this object when it reaches what? Point B. Calculate V at point B. Umbuzo ushonjalo. Now, because on a frictionless surface, then say understand ukuthi the only force that is there is the gravitational force. So we are in an isolated system. In that case, the only force we can look at is gravitational force. Now, using the conservation of mechanical energy, ngoba ayiki friction kusho ukuthi mechanical energy at point A iyalingana ne mechanical energy at point B. So we can now write a formula is what mechanical energy at A is equal to mechanical energy at B. How do we calculate mechanical energy? Mechanical energy is hlanganisa potential energy nani ne kinetic energy. Manje sifune potential energy at A. Masibuka lana singa unpack lo EP. So it's mgh plus ek, it's half mv squared. Formula yakhona then is equal to mechanical energy at point B. Nakhona the formula is still the same. Says you go to a potential energy plus kinetic energy is osnigaban mechanical energy. We can still unpack this one. Says you go to potential energy is mgh, kinetic energy is half mv squared. then singenza yini ama substitutions sibone ukuthi sothola lento siyifunayo. The first thing, i-mass object u5, G is 9,8. We know that. I-height, usikhuluma ngo-point A, the height above the ground ubani u4. Density plus half mv squared. I-mass yazo u5, then speed at point A. Sibo ukuthi kuthiwa it started at rest. When it at rest means what? If velocity is 0. If the velocity is 0 means given the kinetic energy is over O0. Then on the other side, that is the line B. Point B, mass is 5, G is 9,8. Then at B, height, at height at point B, the object is on the same position as the ground. So height yakona O0. So we can replace that one by 0. Plus, we have m, the mass is 5, mass is funabani velocity. This was the question, get the velocity here. So to bani v squared. And so I want to say a unknown aortos, we are going to calculate again what is the v. So in that case, so 30 calculator. Now remember what it's a v squared. Kushoti answer to so the square root of. Right, as one notice over square root gamma. On the other side. So the square root of galana on the left side, so no 5 times 9,8 times 4. Then with denominator, so no 5 over 2, that is 2,5. Right, the square root. Then she was 8,85. 8,85. So if velocity to manu 8,85 meters per second. So to make sugalana from 0 from rest, if velocity is 0, ngesikhathi figure out to point B, if velocity is over 8,85. Logo exchanging, right? It will always remain the same. That's how you apply the conservation of mechanical energy. Now from the same example, what if ngoba siyazi ukuthi isugalana with 0 meters per second, if figure lana 8,85. So ngesikhathi suka from A, velocity ya increase out is figure lana ku 8,85. Umbuzo ungathi at what is the height of the object? My figure ku point X. At point X lambe velocity yakhe ibe ubani? Njengoba ya increase ibe u5. Umbuzo uthi when the velocity is 5, what is the height above the ground? What is the height above the ground? Manje sifuna le height. When we know ukuthi velocity yakubani 5 meters per second, we want to get this height here, right? No, inesingayenza lana sinama point out 3 manje, kuno A, kuno X, kuno B. It's up to you. Ungasebenzisa A and X, uphinde usebenzise bani B no X. Gaja sifuna height at point X, so X has to be in our calculation. Mangisebenzisa point A no X, same principle applies. Siyazi ukuthi mechanical energy at A izolingana ne mechanical energy at point B. So if I break it down, I have mgh at A plus half mv squared at A. This one will be mgh at B times what? Plus half mv squared at B. Right, but this time mina sengisebenzisa banu A no X. So ngifuna mechanical energy at A. So ngingayenza in mgh, the mass is 5, G is 9,8, at X valley height of 4, plus at X if velocity is not 0, sinigwe le velocity to 5 at point X. So then half times 5 times 5 squared, the velocity at point X is equal to, no, lana senze njani ngoba sikhuluma mechanical energy at point A. This simply means that at point A, if velocity yakona ngoba is at rest, the velocity is 0. Sorry for that. Velocity is 0 at point A. Ngoba sikhuluma mechanical energy at A. This is the potential energy at A. That will be 5 times 9,8 times 4. Measure siba no the kinetic energy at A. At A, the object is at rest. So because it is at rest, kusho ukuthi ne kinetic energy is 0. Then sizalana ku X. Ngoba manje so A no X. At point X, the height is no longer 0. Ileyo height sifuna. The mass is still 5. The mass of the object. Then 9,8 times what? The height. That is what we are looking for. Plus the velocity at point X, the kinetic energy at point X, then be half times 5 times 5 squared. Then again, sibonoguti unknown yetu bani h, so we can be able to calculate h. So ungenza ama substitution in that way. When you calculate h, uzoithola futhi answer. Noma umunye umfunda ngathi mina ngifuna ukusebenzisa a no x, ngizosebenzisa bani x and b. Ngoba siyazi velocity at point B. So if I use x and b, I use x and b. It's the same principle that we are applying from x and b. So potential energy at x, the mass is 5, g is 9,8, the height, that is what we are looking for, plus kinetic energy at x, it's half times 5 times 5 squared, ngoba sinikezwe leyo velocity, is equal to, now sifuna a mechanical energy at point B. At point B, the height is 0. Kushukuti will have 5 times 9,8 times 0. Ngoba at point B, the height is 0. Plus, sifuna kinetic energy at point B. It's half times 5. Then sifuna in velocity at point B. Remember that was our first question. Sitoleban a velocity at point B. And stologuti velocity at point B is 8,85. Says fago 8,85 ngala squared. Right? Masenza kanjalo sotola bani. Sotola I height. And the same answer we get here when we can use x and b will be the same answer that we use at a and x. So that's how you use conservation of mechanical energy. Right, leyo bekuyi just a revision from umsebenzi enawenza ka grade 10. Kodwa kubalekile ngoba at this point umbuzo vele uzofika we potential energy, kinetic energy, the conservation of mechanical energy. It's one of the principle, the energy principles. Makuthiwa use energy principles to calculate something, ungasebenzisa na conservation of mechanical energy. It is one of the energy principles. Right, that is the first part. Asizeke kwi-part yesibili ekhuluma ngani nge-work done. Sikhuluma nge-work done. I-work done. Then masikhuluma nge-work done, sithi lo done lo means what? It's done by what? It's a work done by a force. Fanele njalo siku-emphasize lokho. Work done by a force. Then masikhuluma ngama forces, first sibuyele kwi Newton's laws. Newton's laws, and siyazi ukuthi on an object you can have either a gravitational force, noma ube ne-normal, noma singakhuluma nge-frictional force, singakhuluma nge-tension force, noma sikhulume ngani nge-applied force. Those are the forces siwafunda ka grade 12. So you have to be able to draw a free body diagram, so that as long as you are able to find all ama forces, uyakwazi ucalculate in the work done on that particular object. So masikhuluma nge-work done, the formula yakho work done is the force times delta x times cos theta. The theta here is the angle made by the force with the displacement of the object. Right, so for a work to be done, a force must be applied and the object must change the position. There must be what? A displacement. Makungekho displacement kusho ukuthi ayikho nje i-work done on that particular object. Noma ungapusha hlambe odonga for 3 hours, as long as Nyagazangu Tonga, there is no work done on that wall. So you have to, you must have what? A displacement. Makune displacement isuka from position A to a position B, then singakhuluma ngani nge-work done. Right, so that is how you have to understand it. Now, mawubuka ama-forces again, we'll find that some forces will be perpendicular to the object, noma motion. I started an example here. Sinani sine horizontal surface. Now, the forces that we are expecting, we can expect from this one, right? It can either be a gravitational force that is there, a normal force, ingaba kona a force applied, message a frictional force, right? We can expect those 4 on this box. Now, let's just look at these 4 forces. Because we're looking at this object, the object value tendency no right. It's moving to the right. That is the motion of the object. Then cinema forces are 4, right? If force applied the hamsana ne motion ye object. Kushoguti utitawa force applied will be what? Will be 0. Right? Will be 0 in that case. But masibuga nje normal gravitational force asqale normal mabuge normal, the object moves to the right, go to a normal yona ikomba phezulu, so that one in is acting perpendicular to the motion. So angle yakhona u90 and cos of 90 ubani u0, so it means the work done by the normal, it will be also 0. Masibuge a frictional force, it is a force that is exerted on the object. Kotwa yona idonta in opposite direction. My donta in opposite direction, then sotin uti the angle that this force is making with the motion is 180 degrees. And the cos of 180 is -1. Right. If the force is acting at an angle, let's say the force then it's acting at this angle here. Let's in an angle got 10 degrees there. Right. Still, the object izohamba gaga right. Then what we have to know there is that because it's moving to the right, the force applied, even though it is acted at an angle. Now still it's moving what? To the right. So in that case, the angle that sosebenzisa for a force applied is no longer 0. Go back on the angle and sosebenzisa bani 10. It says you go to any angle between 0 and 90. Let's get in over 99,9999. It will be what? Will be positive. Go by the value of the cos is maximum at 1 or at 0 degree. But we are towards 90 degrees, it's decreasing. Because the cos of 0 of 90 will be what? Will be 0. So there are 3 positions here. Koni force ingamsana ne motion, koni force ingaba perpendicular to the motion, then kungaba ne force ezo actor opposite direction to the motion. Locus of sniga 3 types of forces and 3 types of what? Of work done. Now the first one, if the force hamsana ne displacement, they are in the same direction. So sotini the ngoba cos of 0 or positive 1, the cos of 90, normal cos of what? Of 270 is equal to 0. Then we have cos of 180. Cos of 180 is -1. So with these numbers, we formula to cos ezobakon, and from the explanation sizoti, when a force goes with in the same direction as the motion, then city angle U0, and that is +1. Kushoguti layer force le sniga bani I positive work done. Sinani is in a positive work done. Right. Then if we have a force perpendicular to the motion, like in this example, normal spin gravitational force. So from the motion of the object, the normal in an angle gaban 90 degrees. So if it's 90 degrees, then must replace like cos theta, 90 degrees, cos of 90 or 0. So this will be 0. So we have what? A 0 work done. That is a 0 work done. Then we can look at a force that is acting in opposite direction to the motion, right? In that case, the angle isosebenzisa will be what? 180, and the cos of 180 or -1. So masebenzisa any object, any force that is moving or acting opposite to the direction of the motion, then that one will give us what? A negative work done. Negative work done. So those are the three types of work done esokhuluma ngawo. We have either positive work done, lokhu kwenzeka if the force is in the same direction as the displacement or the motion of the object. Sizoba ne zero work done if the force is acting perpendicular to the motion of the object. Then we'll also have what? A negative work done if the object is the force is pulling in the opposite direction or acting in the opposite direction to the motion of the object. That one will give us what? A negative work done. So corner is into two finances like in terms of the type of work done. For example, with frictional force, or by definition, frictional force opposes the motion. So it simply means that jalo work done by the frictional force will be what? Will be negative. Now in some calculations, was ukuthi frictional force is negative work done. It's always opposing what? The motion. By definition, frictional force opposes the motion. So there is no situation where a frictional force is hamsana the object motion. So in that case, it will always be a negative work done. Then for the normal, the work done by the normal is also 0 every time. By definition, normal it is the force that the surface exerts on the object, and it acts perpendicular to the surface. Right, so ngoba perpendicular short is also perpendicular to the motion. So in that case, it's always one work done by the normal force is always 0. So we can see that ngoba sinama forces lana siyakwazi ukuthola formula, because it will be asked what is the work done by a gravitational force. Njengoba sikhuluma gravitational force ifane siyisebenzise, so it will be gravitational force times the distance traveled by the object times what? Cos theta. Theta is the angle made by the gravitational force with the motion. Maguti 0, then you replace by 0 here. It's 1, then it's 270. But most of the time, you'll find that if it's a horizontal surface, value FG uzoba perpendicular, that will be 0. So cos 270 normal, cos 90 degrees, will have that one. If there is a normal force on that object, then certain work done by the normal. Same thing, normal times the distance. This distance is common for all of them. Remember, these are the forces acting on one box, and that box has moved from one position to another. So the distance is the same for all the forces. So cos theta. And so about theta, it's no longer the same theta as this one. FG and here also N, so that you know this theta here is not the same, right? Then the other force, if it's there, so the first thing is to identify what are the forces present. Manga gamma force actor kuleo object. So each force will give you what? A work done. Only if the object is moving. A frictional force. Still so 70 frictional force. 70 is the same distance. So the cos theta. Lo theta where frictional force. For this time we was that theta will always be what? 180 degrees. Go by very low exchange. Then for normal, theta will always be what? 90 degrees. Right, so that you know that every time for frictional force, will always have what? A negative work done. Makune tension, no makune force applied is the same thing. Force applied, so sebenza leo force applied, CT times delta X times what? Times cos theta. Now the theta is the theta angle made by this force applied. Magu are horizontal, then so sebenza cos of 0. If it's at an incline, sebenza leo angle leo that is made by the force with the horizontal. Right. Now, simona ukuthi sinama work done, work done by gravitational force, work done by the normal, work done by friction and so on. Kusho ukuthi siyakwazi ukuhlanganisa wonke lama work done. Masiwahlanganisa sokhuluma ngani nge-net work done. W net. The net work done, that will be work done by all the forces, right? Kone work done by gravity, work done by normal, work done by frictional force, and work done by force applied. So any force that is present there. So before usebenzise le formula, fanube uqale ngokudweba i-free body diagram izokutshela ukuthi how many forces. The number of forces now acting on that object will be the number of work done uzokwazi ukusebenzisa. So the net work done can be calculated using what? The sum of ama work done by all the forces acting on that particular object. But masibuyela kuma forces now. Siyazi ukuthi the object will only move if these forces they give you what? A net force. So ukuthi siyakwazi nakhona ukuhlanganisa wonke lama forces asinike what we call the net force. So masina a net force, it simply means that we can just calculate one work done by that particular net force. Nakhona sotini, so ibiza ngani nge net work done. This time yabo asasebenzisi individual forces. Sesivele sahlanganisa wonke ama forces askiphela bani net force. So the work done, the net work done will be F net times delta X times bani times cos theta. This is the angle made by the net force. Now lo theta lo angaba either 0 degrees or 180 degrees. Fane kube on the same line. Ngoba the object is now moving due to the net force. Right? So maskuluma nge net work done, sometimes ingabizwa nge net work done, noma ikhulunywa ngani work done by the net force interyoto. Makhulunywa the work done by the net force is the same thing as the net work done. Right, that is what you have to know. Right, so we can get an example. So kwazi ukuthola the net work done. So kunendlela eziwu-2 for now. Uyakwazi ukuhlanganisa ama work done by all the objects, noma uhlanganise work done by the net force. Right, so sometimes bangakunika the net force, then uzosebenzisa leyo net force thola bani net work done, then ubuyele kule formula asibize lo formula number 1, formula number 2, indlela yokucalculate ngayo bani the net work done. So from there uyakwazi ukuthola either a gravitational force noma normal force noma ungathola bani frictional force. Kanti uyazi futhi frictional force uyithola ngokuthi frictional force is coefficient of friction times the normal. So ukuthi bangasebenzisa ngisho Newton's second law la bakunika khona i-acceleration mhlambe ne-mass, then bathi calculate the coefficient of friction. Angisho yabo from that case ngoba une-mass ne-acceleration uyakwazi ukuthola bani the net force. Masuthola net force uyakwazi ukuthola net work done ngoba i-distance unikezwe yona. Mawuthola net work done ubuyela ngala ngoba ile formula izokunika bani i-work done by the frictional force. Remember, work done by the frictional force is calculated as a frictional force times delta X times what? Times cos theta. And the same frictional force can be calculated as coefficient of friction times the normal. So umona ukuthi sisuka la from information esinikezwe yona mhlambe acceleration and mass, Newton's second law, sithola banu F net with the net force siyakwazi ukuthola bani net work done. with this formula ye-network done singathola futhi ngoba kuyalingana very the same network done. Sibuyela kule formula la hlanganisa khona ama-work done by all the forces acting on the object. Then from there sithole bani work done by a frictional force. Kanti basithola work done by frictional force, siyazi ukuthi work done by frictional force is frictional force times delta x times cos theta. Kusho ukuthi singathola bani u-frictional force. Masithola frictional force, siyazi ukuthi frictional force is coefficient of friction times normal. This is what we call them a multi-step question. So the total to 8 marks or 9 marks, there is nothing complicated. If I know nama steps soqala utolo F net, sesibili utolo W net, sesithathu utolo work done by friction. Step S4 utolo frictional force, uzofike la kwi coefficient of friction. Then sokuba hlambe ukuthi 8 marks or 10 marks, then we are panicking ngoba ucabanga ukuthi into enzima only to find ukuthi you just have to work through what ama steps and we'll go through. So uzoithola answer yakho. Right. So that is what you need to know about work done by all the types of forces that we can find on the object. Then I insist ukuthi fana ukwazi ukudweba i-free body diagram. Ngiyathemba ukuthi uyakwazi lokho. And for that, we only have few forces, 5 forces in total, and not all of them are acting on the object. Because any object in a mass, it has what? A gravitational force. That one you have to know every time. Matikwa the object, maskuluma object, then you know there is a mass. And if there is a mass, a gravitational force, a cone. Then on the object, you can check whether cone is surface. If it's the object that is hanging, an object hanging shortly object vel ako surface. If ako surface means ako bani, in normal force are equal, right? And so on. You can see that if frictional force won't also be there. Ngoba from frictional force, frictional force is coefficient of friction times the normal. So if in normal ingekho kusho ukuthi in a frictional force are equal. Mhlambe singakhuluma nge-air friction in a case where the object is being pulled up. Air friction. Most of the time uzotiwa ignore the effect of air friction. That is the how to calculate the net work done using different method. Right. Now after this, work energy theorem. Before saying isbalo, work energy theorem. From a formula sheet, we go to W net is equal to delta EK. From a formula kwa yona, it means what? Stand for Leo statement. Work energy theorem. Intehlanganisa energy ne network the network done. Ngakho sibiza nge work energy theorem. From the formula, we just need to say this in word. The network done is equal to the change in the kinetic energy. So you are told 2 marks work. That's why bati state in word ngoba usunikezwe yona as in symbol. W net is equal to delta EK. The only thing you need to do is to say this in word. Ungashi W net, just say this is the net work done. Or equal sign is equal to the net work done on an object is equal to. This means what? A change. This is kinetic energy. So total 2 marks work energy theorem. And so yabona age manje from the formula wama W net, the first one sahlanganisa ama work done by all the forces if akon, work done by the normal, work done by force applied, and so on. Then yesibili instead the net work done is the net force times delta x times what? Times cos theta. Then at the start to W net is equal to the change in EK. And it's about from the first two, fana kube khona in a force. What if abaknigi force then bakniga in if velocity no speed say object. And so abona again uyakwazi kusuka from the speed of the object ngoba uyakwazi ukuthi if there is a change then we'll have what? The network done. Then from there ngoba uyakwazi ukuthola network done usebenzisa ama speed kusho ukuthi ungakwazi ukuthola network done. Mothola network done ungabuyela kule formula noma ubuyele kule formula sekuyisabani kuma forces, ekuyisa kuma forces. That's how you work on with this network done. As I said earlier on, kuna multi-step questions. Kuna multi-step questions. Right, let's look at one example here. Right, using what the network done and the work energy theorem. Right, an object is moving from this point. Let's say ihamba with speed of 3 meters per second. Isuka from point A. Then izohamba a distance of 10 meters. Ize ifike la izoma khona here. It stops. Right, behamba from point A, figure at point B, where the object will do what? Will stop at point B. From point A to point B, there is a distance of 10 meters. This object has it 2 kg, right? It is 2 kg. Now, we need to find what is the coefficient of friction. What is the coefficient of friction between A and B? Right. Now, what if the question is to calculate a coefficient of friction? At this point, calculate a coefficient of friction, so a formula, frictional force is the coefficient of friction times the normal, right? So that's your was tolerant. Now, a coefficient of friction will be what? A frictional force over the normal. Now, in normal, was we told ngoba vel sine mass. So the normal, it's easy to get. In normal, in this case, ilingana na FG, it will be M times G, and that will be 2 times 9,8, 19,6 newtons. So normal force scenario. The problem is a frictional force. Do we have a frictional force as scenario? But this object here, it did work. There was the work done on this object. Goba isuge from A, ya figure B due to ama forces. So we can start by drawing what a free body diagram at this to this object. Now to have a free body diagram so that we understand ama forces. A gravitational force stays scala ngayo njalo. Then there is a normal force acting on that object. Now, what is the other force? Aiki force applied ngoba siyiboni la. Then siyazukuthi from A to B there is a frictional force. So a frictional force ihlezi idonsa in a backward position. The object is just moving from A to B. Abashongo there is a force pushing it, but it's just sliding from point A to point B. Kota izoma at point B. So those are the 3 forces acting on that particular object. Right. Now, kutiwa as calculate coefficient of friction. Into sifunayo a frictional force. Do we have a frictional force as now? Go back with finally 7 zise a coefficient of friction and normal. Lana kutiwa si calculate bani a coefficient of friction. So what we have to do here is a frictional force. In net force as years now, at least we could know what is the net force that is acting on the object. So because there is a change in velocity, velocity is 3 here. When it has stopped, velocity will be what? Will be 0. That change in velocity will give us what? A network done. And this apply a work energy theorem. So the network done is equal to the change in the kinetic energy. So in that case, here, the kinetic energy is half mvf squared, the final velocity, minus half mvi squared, initial velocity. So in mass energy substitution, that will be half, the mass is 2 times vf, final velocity is 0. Goba initial velocity was 3, figure laba 0. That is 0. Minus half times the mass is 2, initial velocity is 3 squared. So at the end, the net work done at this point will be what? Will be negative 9 joules. That is the net work done on the object, to negative. Right. Now i-network done ngoba besebenzisa ama velocities, na asibuyele kwi-network done ezosinika bani ama forces. The network done ezosinika ama forces. Now this was the first formula ye network done. Now if formula ezosinika network done isebenzisa ama forces yona ithi the network done is equal to the work done by asibukela ama forces akhona normal, the work done by a gravitational force, and the work done by a frictional force. Those were the three forces ngesikhathi sidweba a free body diagram. Right, here it is. Now sesiyathola i-network done sebenzisa bani the work energy theorem or change in kinetic energy. And sithole bani negative 9. So tilana negative 9 is equal to work done by the normal, sithe earlier on ihlezi ubani u0, plus work done by gravitational force. Futhi siyabona ukuthi from this object, even though the object is hamba ngaga right, the gravitational force is perpendicular to it, and sithe if the force act perpendicular, a work done will be what? Will be 0. Then plus bani work done by frictional force. So in that case ngathini, from what we've done sesiyathola ukuthi work done by frictional force ubani negative 9 joules. Sesiyasondela ngakhona ngoba sesine work done by frictional force. Now how do we work out a work done by frictional force? The work done by frictional force we calculate as a frictional force times delta x times what? Times cos theta. The work done by frictional force says here negative 9 ngoba sithole from this initial formula. And so about saying we start man. The first step was to calculate the network done using a velocity ngoba there was no force that was given. Then sebenzisa leyo network done uthola bani work done by frictional force. Now saying ngiyakwazi ukukhuluma ngama forces. Then mase ngithola work done by frictional force, ngiyakwazi unpack leyo formula. Work done by frictional force is equal to frictional force times the distance times delta x. So lana ngizothi it's frictional force times delta x negation is 10 meters times cos theta. Cos theta ubani cos ga 1/8. Remember for frictional force the angle is always what? Always 1/8. So from there singathola in a frictional force. So our frictional force will be what? 9 will be 9 divided by 10. Sinobani 0.9 newtons. Sesinani sine frictional force. Sesiyakwazi ke calculator ini coefficient of friction ngoba a frictional force iti coefficient of friction times the normal. So sina frictional force u 0.9 sesige some calculator lana sifune coefficient of friction. I normal si calculate earlier on. So loti normal 19.6. So we have 19.6. So we can get what? A coefficient of friction. So that will be 0.9 divided by 19.6. This one gives us what? 0.046. Right? That's how you use all those formulas in terms of how to get the coefficient of friction. Now, when you look at the steps, we are going to go to okay, sisugala for information esinayo. What we need ifanele ubhala iformula yalento ifuna izo guide ngoba besifuna coefficient of friction. Bhala iformula coefficient of friction. Then uzobona ukuthi yini oyidingayo. I-normal force yakwazi ukuthola. I-frictional force yona inkinga sefanele siyithole in that way. Right? So when you work in that way, uzobona ukuthi umbuzo mhlawumbe uzothi 8 marks noma uthi 7 marks. And it's just an easy thing, just that you have to go what step by step. Information nginayo ama velocities. Ngiyazi ukuthi makushintsha nje velocity kusho ukuthi nginani ngine network done. Leyo network done mangiyithola ngiyakwazi ukuthola work done by each and every force. Mangithola the work done by each and every force, ngithole work done by leyo force engiyifunayo, that is what? The frictional force. So mase ngithola work done by that frictional force, ngiyakwazi ukuthola frictional force by using what? This formula here. Mase ngithole frictional force bese ngibela kwi steps okugcina when I get to what? To the coefficient of friction. Right? Siyabonga abafundi ukuthi today we could cover this. So next Tuesday sokhuluma nge-work done siyiqedele-ke le topic, and siyabonga for today.
Siyathemba nifunde kahle nasithokozela isifundo sethu sanamhlanje enisethulelwe ngezilokotho ezinhle Ithala libambisene ne-Go Digital SA Foundation. Thamelani ke futhi esilandelayo ngesikhathi esifanayo. Ningakhohlwa ukumema nabanye abafundi bebanga le-12 ukuze nabo basizakale kulolu hlelo. Uma ninemibuzo noma nifisa ukuxhumana nathi, ningasithinta ngokufaka imibuzo yenu kwinombolo yethu ye-WhatsApp ethi 068 151 1072. Mfundi, ungakhohlwa ukubhala isifundo obuza ngaso ngaphambi kokubhala umbuzo wakho. Angiyiphinde inamba yethu 068 151 1072. Siyabonga.